Assalamualaikum and salam sejahtera to all lecturers. Today, I will present my proposal for final year project on indoor air quality assessment at paint manufacturing industry in Bangi, Selangor. This is the outline of my presentation. First, introduction. What is indoor air quality? According to United States Environment Protection Agency, indoor air quality refers as air quality within and around buildings and structure, especially as it relates to health and comfort of building occupants. It is estimated that around 90% of people spend most of their times at private or public environment, such as home, school, workplace, transportation vehicle, and etc. Paint manufacturing industry generates fugitive dust during operation. Thus, exposure to it may cause health risks to workers. Workers exposed to pollutant at workplace through inhalation, ingestion, and dermal contact. The most common is through breathing. Volatile organic compound, often referred as toxic or hazardous air pollutant. In paint manufacturing, solvents that are used usually contain benzene, toluene, and or xylene. In paint, generally consists of 4 components: pigment, resin, solvent, and various additives. Prolonged or high exposure to paint and paint fume can cause headache, trigger allergies and asthmatic reaction, and also can irritate skin, eyes, and airways. There are 2 common health effects of indoor air pollutant: sick building syndrome and building-related illness. Sick building syndrome is a non-specific syndrome that occupants will experience when in building, while building-related illness is a well-identified illnesses such as asthma, hypersensitivity pneumonitis, and humidifier fever. Therefore, it can cause absence of worker and low productivity at workplace. Next is a standard that are referred in Malaysia. It is Industry Code of Practice on Indoor Air Quality 2010. First is acceptable range for physical parameters. Next is acceptable range for chemical parameters. And last is the acceptable range for biological parameters and ventilation performance indicator. Literature review. In the case of dry air, it can lead to various types of illnesses which can disturb airway system. Particulate matter contains microscopic solid or liquid droplets that are so small that they can be inhaled and cause serious health problems. Toluene and xylene could result in serious neurosis. Chronic toluene exposure leads to devastating neurological disorder, which dementia is most often. Long-term exposure to xylene may cause headache, extreme tiredness, and impact concentration. The most abundant species in the stack emission and the fugitive emission in paint industry are ethyl acetate, acetic acid, butyl ester, and ethyl benzene, toluene, styrene, and ampicillin. Problem statements. In industrial sector, indoor air pollution is considered as one of the main causes of work-related disease. This is because uncomfortable environment can affect work performance. Exposure to benzene, toluene, and ethyl benzene is associated with a decrease in forced expiratory volume in 1 second and with an increase in change of forced expiratory volume in 1 second. It is estimated about 20 to 40% increased risk of certain type of cancer, in particular lung cancer for those come into regular contact with or work with paint. Research justification. People thought stay inside in the room are the safest place. Poor indoor air quality can cause a variety of health problems ranging from temporary and long-term health problems. There are less data about indoor air quality at paint manufacturing industry, especially in Malaysia. Research question. Is the status of indoor air quality at paint manufacturing industry complies with the acceptable limit based on Industry Code of Practice on Indoor Air Quality 2010? General objective. To determine the level of indoor air quality at paint manufacturing industry. There are 4 specific objectives. First, to measure physical, chemical and biological parameters of indoor air quality at paint manufacturing industry. Second, to compare physical, chemical and biological parameters with industry code of practice on indoor air quality 2010. Third, to compare of total bacteria count and total fungal count between sessions at each sampling point. Last, to compare indoor air quality parameters between stations at paint manufacturing industry. Hypothesis: indoor air quality at paint manufacturing industry exceed the acceptable limit based on industry code of practice on indoor air quality 2010. Next, methodology. It involves three methods: walk-through survey, questionnaire, and sampling of indoor air quality parameters. Research flowchart. First, site visit. In this, sampling involves qualitative and quantitative method. Qualitative is walk-through survey and questionnaire, while quantitative method is measurement of indoor air quality parameters, data analysis, and lastly, we will conduct statistical analysis. Study location is at paint manufacturing industry in Bani, Selangor. It involves of 6 specific locations. It is reception counter, storage area, and 4 office rooms. Study design. This is a cross-sectional study to evaluate the level of indoor air quality at paint manufacturing industry. First, walk-through survey. The survey will be conducted during working hours. It is aimed to obtain this information. First, general check on the presence of odor, dirty condition, and etc., human exposure and comfort levels, potential source of contaminants, and last, ventilation and aircon conditioning system. Second is questionnaire. A set of questionnaire will be adopted from ICOP 2010. The questionnaire will include general information, background factor, nature of occupation, environmental condition, past or present disease or symptom. The questionnaire will be distributed to the workers at the selected location. Third is indoor air quality parameter sampling. All sampling will be performed within business hour from 8 a.m. to 5 p.m. to represent the real-time analysis. For physical and chemical parameters, they will be conducted with direct reading. The measurement will be conducted at 4 time slot, which evenly distributed over the business hours. In this table, this is the time interval for the sampling. Next is sampling tools for the measurement of all the parameters. First is hot wire velocity meter for the measurement of air temperature, air movement, and relative humidity. Second, formaldehyde meter for measure formaldehyde. Next is Aeroca 500 for the measurement of TVOC, ozone, and carbon dioxide. Theta 3 measurement for carbon monoxide. EVM3 is used to measure particulate matter. And last, MAS 100 Eco Microbial Air Sampler is used to measure total bacteria count and total fungal count. Procedure of agar. Trapticus soy agar will be incubated for 2 days at 35 degrees, while Soberes Ditotres agar will be incubated for 5 days at 31 degrees after the sampling. Then it will be continue with colony counting. This is the calculation of colony plate. Colony that have been count per plate is then converted in the form of CFU per meter cube. That is the last unit for the calculation. Next is statistical analysis. First, to compare the total bacteria counts and total fungal count between sessions at each sampling point. If it is normal, then independently test. If not normal, man-Whitney you test. Second, to compare the indoor air quality parameters between stations at paint manufacturing. If normal, use one-way ANOVA. If not normal, use Kruskal-Wallis. Next is Gantt chart. This is the planning for my 1-year research project. Last, this is the references that I refer for my proposal. That's all. Thank you.